Okay, welcome back, America. Welcome, Taylor Swift. We are going to do a problem where we verify that f and g are inverse functions. So let's go ahead and start. So in order to do this, we have to check to make sure g of x, when we input it into f of x, it undoes f of x. And we have to plug in f of x into g of x and make sure it also undoes f of x. So we should end up with x when we do that, which is our input. And if it works for one and not the other, then the functions are not inverses of each other. And so we have to say they're not inverses and then say why. Most of the problems you get in pre-calculus are inverses of each other. So it's very rare that I see a problem where I ask you to verify that two functions are inverse functions and they're not inverse functions. Okay, because we're learning, but you have to make sure you do both. And the number one common mistake, phone should be away. The number one common mistake is to just input g of x into f of x and then just say they're inverses. You have to input f of x also into g of x. So it looks complicated when you do it, but they should undo each other pretty quickly. So let's start with, and it doesn't really matter which one you start with, but I'll just start with f of g of x. I'll input g of x first. So here's our g of x, and we're going to input this into f of x for x. Now, before we start, I just want to show you this negative is in front of this entire expression here. So negative, and then there's a parentheses in front of every numerator and denominator, right? We talked about that, x cubed plus 6. So you can think of this as, if I put negative in front of a 1/2, right? That's like negative times the 1/2. That is the same thing as if I wanted to distribute the negative to the numerator, it'd be negative 1/2, right? It's also the same as if I wanted to distribute the negative to the denominator, 1/2. It's all the same thing, okay? We're not gonna have to do that here, but I just wanna show you that if I wanted to distribute that negative to the numerator, the numerator would have to be negative x cubed minus 6, right? Because the negative is in front of the whole fraction. Are you with me? Should I repeat that? All right, let's do it with numbers. Okay, no, let's not. So let me just rewrite. I'm going to distribute the negative to the numerator. There we go. This expression is the same as that one. Here's another one that's also the same. I'm going to distribute it to the denominator. They're all the same. Where it gets complicated is if I chose to distribute to the numerator, because there are two terms in the numerator. And so if you're distributing a negative to an expression that has more than one term, it has to be distributed to every term inside that expression. That's what I was getting at. All right, let's go ahead and plug it in. So we've got, all right, equals, and I'll write it down here. The cube root of negative 8 times, and I'm going to break the whole thing, negative x cubed plus 6/8. That's our new x, minus 6. Okay? Now, instead of distributing that negative to the numerator, this is like a negative 1 times that fraction. And we're also multiplying that negative 1 by this negative 8. We're also dividing by an 8. So we have a negative 8 in the numerator, and we also have another negative inside here and another 8. Those are going to cancel. We're going to be left with x cubed plus 6, and then a minus 6. Yep.
What would happen if it was a different denominator? Like, will it always be the same for the...
Well, if they're inverses, everything should cancel beautifully.
Okay.
If it doesn't, then they're not going to be inverses. So this would then be the negative 8 and that negative 8 will cancel, and we're going to end up with x cubed plus 6, I don't like this black line, but it's fine, minus 6. And those are going to cancel as well. So now we have the cube root of x cubed, which is just x. That one undid itself beautifully. All right, we're on the way to these functions being inverses, to verifying it. But we also have to check g of f of x and make sure that undoes the function as well. Okay, so let's go ahead and try that. Oh, I'm going to use Mario's trick here. Come on. Did this work? Oh, there we go. Boom, baby. Booyah. Okay. Really have to hold this down for quite a while. Why?
No, you just hold it and release.
Really?
I think so, yeah.
All right, I'll try it next time.
Wait, so 2 negatives?
All right, so let me try in a different color. You guys can keep talking. Okay. Yeah.
We have a question about what happens to the negative in the square root with the fraction.
This is a negative times a negative makes the fraction, the negative times a negative is positive.
But it canceled out? 2 negatives canceled out?
Mm-hmm.
Okay, I was thinking about it like negative 8 plus 8. Okay.
Because that's what I was trying to explain with the distribution. This is like this part right here is like negative 8 times, and then this is like a negative 1 times x cubed plus 6 over 8. Are you with me? So the negatives are going to cancel, and then now you have an 8 in the numerator and an 8 in the denominator, and those are going to cancel.
Okay.
So that's why. Okay, so let's go to g of x. And now in green, let's take, this is now our input. We're going to input that in here for x. See what happens. Negative cube root of negative 8x minus 6. And that whole thing is cubed plus 6 over 8. Right? Did I do that right? You guys are checking my work. All right, so we're cubing a cube root. So what's inside there is just going to be, and we have the negative in front. Let's see, negative, and this is just becomes a fraction here. Negative 8x minus 6 plus 6 over 8, right? Hey, we're getting somewhere. These 6's are going to cancel.
I have a question.
Yep.
So wait, it says negative 8x, right? Is that a negative sign right before that too?
Yes.
So would it become positive then?
Hold on. Well, we're not there yet. I'm just going to leave it out there in front for now. So we've got, all right, so we've got a negative, and then this is a negative 8x over 8.
So
Now the negatives are going to cancel, just like you said.
Yeah.
And the 8's are also going to cancel.
So it's just x.
So it's just x, which means we're good. Every once in a while you get a problem that says, x and negative x, or something that's close but not exactly the same. This is x. I'm running out of room. So those two undid each other as well. So we checked both. We're good. If you were asked to verify that two functions are inverses of each other, you've got to check both. You've got to plug one into the other and one into the other and make sure they both undo to x. Yes.
When we're finding f of g of x, why do we put a negative in front of the g of x? Oh wait, never mind. I see it. Never mind.
Yeah,
Never
because it's
mind.
inside the function.
Yeah.
All right.
It's
All
right
right.
there.
That's it.